Alrighty. Happy Thursday. So first things first, we have a pretest that I just got. Um, and not a big deal here. This goes pretty quick. If you would be so kind as to do this at some point in the next couple weeks, great. Preferably before you give me the final project. I think would be a good timeline for that. So um, it's just a couple questions, and it's all C++ based. So if you came here from Python and you didn't do C++, let me know, and I will get you a different version. Because, yeah. So arrays, this one is um, class here, so you have to write the member functions, which is very exciting here. Um, it, so they want you to write those four functions here that are defined in the header, right? That part make sense? Okay. Um, Yay pointers. And then one on template types here. Unsorted array or type class T, a length. Sure. Nothing too crazy, I'm assuming. After you got through 200, you're probably in 350 at some point, or I might have already taken it here. This should be pretty quick for you. Um, but we'll do the pretest here. Apparently, this was a CIS 200 test at one point. I don't know, just based on the footer here. Again, this is what I got emailed to me here and said to give to my students. So if you'd be so kind as to fill those three out here, you are welcome to type it here. I think enter '03. Oh my goodness. Is that really '03? That's 22 years ago, right? Yeah. Holy cow. This test is older than some of you. Okay, this is what it is. Don't print it unless you would like to. Feel free to just type in it here. I assume they were probably printing these at that point and handing them out and having people write code by hand with a pencil, which sounds terrible. Please don't write code with a pencil. Um, has anyone made you do that here as a student? Yeah. Seriously? Yeah. Writing code with a pencil. Do they know computers exist? Oh my goodness. I'm sorry. I have strong opinions about stuff, so but I don't get to make the rules, unfortunately. So I'll go drop that in here, and then you need a place to submit it. So I probably have to put it like in a as an assignment, so you can submit it here. Uh, Assuming you can all open Word docs, I can make it a PDF if you need a PDF. Let me know. Um, but there's the pretest. Make the assignment here. Um, you can have 1 point for a project, sure. Um, Pretest. Do what like how about December 4th? Is that okay for 1 point? Link to course files, pretest. Please take this at some point this semester. Right, and then you will turn in the file. Online file upload. Questions? That make sense? Okay. Again, sorry for the late notice on that. I just got it, so. Uh, right, I'll even put it at the top. We got lots of emails on Sunday because the grader had a slight mix-up, confusion here. My apologies with the default template that IntelliJ has. They emailed me after they scored everyone here, and sure, she's a poor grad student who's had everything scared out of her that she'll get kicked out of the college for cheating with AI. So if you would kindly give her a little slack as she rescores those here. Having this exact same comment at the top of most of your code is not cheating. It was not the use of AI. We've had a conversation. If you had questions about project 1, let me know. I think all the questions except for one person were about project 0. So if that's incorrect, let me know. I'm happy to have that conversation with you as well. But hopefully moving forward, things will go well. But they're apparently terrifying all the grad students about using AI tools and getting kicked out of school. So I don't know. That's the best I got for you right now. Uh, so if you would kindly ask her the question first to look at it again if she hasn't, and then if you're not getting the response you want from her, come ask me. But please do ask her first. Is that okay? All right, cool. Sorry if you panicked that there. Um, I don't know. I don't know what happened. It's okay. We'll figure it out. Project two, hopefully that's going well for you. Um, Again, take a look at the last bit of lecture. I would strongly recommend you serialize everything and just dump it. That will make your life way easier for saving and loading. If you can serialize everything down the chain, it's just one save, one load. Works out really quickly if you structure things in a nice object-oriented manner. So again, hopefully you've learned a little bit here, and you're seeing, and this is your chance to experience that the way we design software determines lots of things about it downstream. Right? How well we can test it, how well we can do all these sorts of things here. So spending time designing solutions here is going to be well worth your time, right? Because you want to think about how everything is organized and laid out here, and what classes have attributes of other classes that have attributes of other classes, and that sort of thing is perfectly fine, right? We can organize our code in such a way that it's easy to talk about, right? We like our nouns, and our nouns have attributes, and attributes of a noun could also be another noun. So classes can have instances of other classes as attributes. That's perfectly fine, right? A Monopoly game class can have a list of properties, right? It can have a list of players as attributes. And if we've done that all the way through and all the classes are serializable, we can just tell Java, hey, write it to a file. And then we can tell Java, hey, load it from a file. And then everything gets saved and loaded for us, which is pretty nice. We don't You can definitely do it with a text-based file, and you probably did that in a 150 or 200 class, depending on who was teaching. You probably wrote a text file that had, oh, here's my shopping cart, and the first line is going to be the first item's name, and the second line is going to be the first item's price, and the third line is going to be the first item's quantity, or something like that. And you had to read a bunch of lines out and rebuild these instances from scratch. That's a big pain in the butt. You can definitely do it. It's a pain, right? So again, I'm quite fond of the easy approach. Let's make the tool do the work for us here. Um, so either way should be fine. Just pay attention to the rubric here, right? Make sure you have classes for gameplay. So this is an object-oriented approach. We can't just have one big main function, right? 10 of your points come from having classes, okay? If it's just one class and you made it work, yeah, you probably need more than one class, right? Maybe you could. So just having classes gets you a third of the points here. It doesn't have to be functional. You just have to have the classes, right? The functional bit here gets you another third of the points here. The game actually works here. And then the last third of your points is you can save and load. Again, strongly would recommend serializing here and just dumping. Works out pretty quick. But does that make sense from last week? Okay, cool. Oh, the syllabus quiz. Did I mention that? Please just take that real quick. It's a one-question quiz. You've acknowledged the academic integrity policy for the course, and this is part of the paperwork I have to turn into the dean's office when I fail people for cheating. And I tell the dean, hey, look, they acknowledged the policy, right? Because apparently putting in my syllabus is not good enough. You would think adults would read the syllabus, but okay. That's all I got. All right, so topics for tonight. More fun, new stuff here. Now, depending on how far and how much attention you paid in C++, most of this will not be new here, right? We're going to look at how to do some of these cool object-oriented programming things in Java, right? So we've got chapters 10 and 11 here, which is all about, oh goodness, here, inheritance. Okay, we'll look at specific pieces of inheritance, and we're going to look at using interfaces and abstract classes as well, and interfaces, enumerations, packages and libraries is other fun stuff. There's interesting rules. Java is very convention-based when it comes to this. Modules. I'm going to skip the Java doc part. They would still like you to read through it at some point, and it's possible to be on the quiz because I use the book test banks here for the quiz. But I'm assuming at this point you've programmed for a couple semesters, you could probably figure out how to write a comment. Is that a fair assumption? Okay. That's not the hard part here. All right. So we fire up IntelliJ here, and I did finally get the new version here. So I have the latest and greatest version, which is very exciting because they want to sell me everything. and I'll start up a new project. So this is, I should be able to count here, right? Week 5, week 5 already. We're a third of the way through the semester already, and it's not even October yet. It really does. I don't know how that happens every time. So again, I'm putting it in my repository. You'll put your code in your project repository so that it goes there, different from your other project repository. If you're having trouble with it still, let me know. We can make things work pretty quickly here. So this is more object-oriented programming. Don't check the create Git repository box. Don't put Git inside of Git because it confuses Git. Sample code's great. And again, this sample code bit here with this latest and greatest version is what seemed to confuse our poor grader here. I delete all these because they irritate me, and I don't like having the sample comments in here. And that's probably why it wasn't in my example, but that's fine. So we'll delete all those ones out and then get rid of our tip here as well. Very exciting. There. And now we're back. Did I have? I think they gave me a breakpoint. Okay. So again, our class here, public class main. I'm just going to leave this one alone. I'm going to write new classes over in this new package, in the source package. We'll look at modules in a little bit, next chapter here. So I'm going to go add a new class, and we can do the boring polygon example just to go through it quickly here with inheritance. Is that okay? Probably don't need super interesting examples here. So my class for polygon here probably has an int for number of sides here. And then if we wanted a way to store the lengths of all those sides, we could have an array list of integers for the length of the sides, or an array of doubles if you wanted to be specific and have weird decimal places here. That's probably fine too. But I want to use the array list. So I want an array list of type, I guess we'll do double. Why not? For side lengths. And, oh, you have to use the class wrapper, right? We're using array lists. So the lowercase primitive double doesn't work, but the capital D double class does work here. And now it doesn't like array list. We can go and import that. Great. And oh yes, this inline completion is very exciting. It actually does a lot of stuff. This is probably exactly what I would type. So I'm not really offended at this one here. And it's going to save me a little bit of time. Would you rather I have this off? And I can do it all by hand, but if you have it on, I'm okay with you using the inline completion. I don't want you using the full-on AI suggestion everything tools where it gives you everything, but it's suggesting one line at a time of things you would probably write is probably fine here. I'm going to be okay with that. Is that fair? Okay. So leave it on. Okay. So it's suggesting a constructor. Sure. Number of sides. Now, this is not complete. This was not actually a great suggestion. Again, this is one of the reasons that we're critical of these tools here. And as you're learning, they're really bad if you don't know that they're not good. Is that okay? You don't need me to lecture more about AI nonsense, do you? Sure. So not everything I wanted. There we go. Oh, now this side length is my side lengths here. This is still not great though, because remember, if you have an array list, that's your memory address to where that array list is stored in memory here. So I've taken the array list you gave me, and I'm pointing my array list at that one in memory. Now, if I want to maintain the integrity of my class, someone else has access to change my array list. That's probably a bad thing. Right? I don't have a copy of it here. So we probably want a copy of it here to make sure that if we're doing something to make sure I get good values for side lengths, we're doing something about it here, right? So I'd probably go through and make a copy of these ones here, right? So we can, I think we can use the .clone. I think we should be able to use, does it not let me use clone? Oh, I have to cast it here. So cast the expression to an array list of double here. And now unchecked cast, yeah, that's going to be fine. It's concerned, but it should be fine here. So we've cloned it. We know it's doubles. It should clone perfectly fine here. We should be in pretty good shape. So you tell me how many sides, you tell me the length of their sides, great. Now you might also want to make a constructor where you just tell me how many sides it has and you don't know the lengths yet, and we can go and add them. Right? That might be a valid option here. So we'll make another constructor, and again, we can just generate our code here. Like the inline creation is basically the same thing as this here, right? And then my side lengths will equal a new array list here. Just starts empty. If you want, we could size this, and we probably should, right, to our number of sides. So one of the options when we create array lists is how many items are inside of it. If we can get our little telesense working. Is it going to work for me? No. Why is it not suggesting it? I just want it to show up and it's the size of the array list. Well, that's fine. So now we'll have that many indexes available to us here. Okay, so if you give me side lengths, though, we probably want to make sure they're valid. Here again, right? Good object-oriented property principles here. Make sure we're never in an invalid state. So a side length probably has to be more than 0, right? So we want to make sure they're all greater than 0, right? So we can go through for double side length in side lengths, right? No, I don't want to go add. Choose key for completion. Yeah, the tab key is great. We don't want to do that. We want to say, hey, if the side length here is less than 0, wow, look at that. Throw in legal argument exception. This is pretty handy. It's even faster. And it's giving me a decent exception here, right? Very exciting. So we'll go through and check them all. Make sure it's a forceful check here. You have to go and catch the exception and do something about it here. You will not create a polygon with an invalid side length, right? Okay. So we can do that. Now we probably need a way to go and get the side lengths and set the side lengths. Now, getting them, sure. But again, this is giving you someone else access to my array list. This is probably a bad idea here. So I'm going to go with the clone option here and do the casting. And let's go through and say, yes, let's cast and say, yes, I really want this type here. I know clone is not very good here, but this should be fine. Yeah.
I'm sorry, what is clone again?
So it's making a new copy, a new array list here, because I don't want to give you my array list, because then you can go and modify the values outside of my code. So I'm going to make a copy of that array list so that if you modify something, you didn't modify my version. So it's going to protect the integrity of my side lengths, because we're saying you can't be less than 0 or less than or equal to 0. We should have checked that here. 0 is probably invalid, right? So we're going to make sure that they don't change outside of my control. Right? And then we need a way to go and set the side length. So void set side length, set. I don't like setting all of them here. Right? I think we want to set one at a time. Right? If you wanted to set all of them, you would have given it to the constructor. I don't think, it depends what you want to do, right? It's up to you. It's your polygon, but I just want to be able to set one side length. So we'll say an int for the index and then the double for the length. Right? So you tell me, look at that, set a given index at the given length. But again, we should sanity check this here, right? Make sure that my length is not less than or equal to 0. Look at that. So now my error lies here, right? I changed my code, but I didn't change my comment, right? It has to be greater than 0, not greater than or equal to 0. So this autocomplete stuff is dangerous, right? Okay, so if it's valid, go and set it. We probably don't need to sanity check index, because if you give me an invalid index, the array list is going to puke and throw an exception anyway, right? I don't need to write a bunch of code that does my own exception, because this will already do an exception if you give me a bad index, right? I'm probably okay with that. All right, very exciting for our polygon. Now, one of the last things we should be able to do with the polygon is be able to get the perimeter. Right? For any given polygon, the perimeter is just the sum of its sides. Very exciting. So we'll make a double get perimeter. Look at that. And we're going to return. I can't sum right away, sorry. So we'll have a double for the sum. Start with 0 and 4, double side length and side lengths. Take the sum plus equal to the side and return the sum. Right? Very exciting. Reassigned local variable. This? I'm confused by that one. That's what? All right, I don't know. That's okay.
Just saying that it's updating now.
It's reassigned. We're adding to it. We're not reassigning it. I'm not really sure. Honestly, that one confuses me. Not sure. But probably okay at this point here. Right? So now we should be able to go and make some polygons. Again, we should write some unit tests to make sure it does what it's supposed to do. Okay, let's go for it real quick. So we'll go and make a test. Go to test, and I'm going to argue this is the right way to do it, not to add some code in main and run it by hand. We certainly could, but we're bad at that sort of stuff. Right? And I want to have tests to exist, so eventually we can run more tests, because this Polygon code is so good and amazing. I'm sure it's going to live forever. Everyone's going to use it, and we should maintain tests in our library for Polygon. ideally you write interesting code for your job that stays around here, not boring throwaway code for examples, right? But again, we'll go and try that here. So JUnit 5, great. We want to test the get perimeter. I don't want to test all of the set side length and exceptions, but we should do that. Is that okay? I just want to have one test here for perimeter. That should be okay. And hopefully these red lines go away if we import not JUnit 4, right? Sometimes the red lights are bad, right? Make sure we import JUnit 5. And it should go away. Fantastic. We're going to arrange, we're going to act, and we're going to assert, right? So we need an array list of type double for lengths, new array list of type double. I think, can we just use this syntax? 1, 2, 3, 3, 4, 5. It's a 3, 4, 5 triangle, right? It's a valid one. Doesn't like that. Array initializer. There we go. Really? Did it not? Oh my goodness. Array list initializer. Initialize with values. Really? Did we do this last time, right? Yeah, we did this last time, didn't we? Arrays as value. Oh, so ugly. Arrays. Import that one, sure. As list, sure. 3, 4, 5. And too many not enough parentheses. Array list. I think this is 3.0. Nope. 4.0, 5.0. Do I have to change all of them? All right, we have to change all of them to doubles. Thanks, Java. That's helpful. Lovely. All right, now we got that. And then act. So the act is we're testing perimeter. So I'm going to make my polygon here. Polygon, polygon. There's a new polygon given 3 sides and my lengths array list here. Then I need a expected perimeter parameter here. I think that is 12.0. That's the double here. And then we'll go get the actual. So our double actual perimeter is my polygon. Get perimeter. Oh, can't spell actual. And then we can assert. Assert equals my expected, my actual. And I shouldn't need the delta for this one, right? Because they should add up okay. We'll see if that works. Right. Very exciting here. No, not that button. We want to run tests, not debugger. Do I not have my run test? Run. No, just run. Where'd my button go? Usually you get the little triangle button. I'm so sad. No? Oh my goodness. Did tests. Sure, run the current file. It's not even letting me do that. I'm sorry. Run. Edit configurations. What? Really? That's depressing. Is it in my... Where do I get my test menu? This is not going well, friends. I'm tired. Controls, no. Import tests. Run. There's the test history, but it's not showing there. Are any of these ones my tests? Run. Run. Right, this one will run. I should be able to go run my tests next. It shouldn't do anything. All right, nothing happened. Now can I run tests? Now it runs tests. I think it had to go through the build first. That was probably what it was. I had never built it before. All right, now we get a run button here and it will run tests. Thank you, IntelliJ. It's amazing when the magic works. And our test passed. All right, very exciting stuff. You're all amazed. So if we want to take this class and make a special version of it, we like everything it does. We don't want to reinvent the wheel. We want a version of it that's slightly different. Enter inheritance. right? That's one tool we have in our toolkit that allows us to create a new version of this class that is a polygon still, but it's a specialized version of polygon, right? If you just want to have polygons, you don't need to use inheritance, right? It's not a has a relationship, it's an is a relationship. So if the new class is a polygon, but it's special, then we can use inheritance, right? Uh, Typically, once we start talking about inheritance and we get deep into that in 200, you get weird stuff where students create files and like their menu is an instance of or inherits from the game class. Right? Your menu is not an instance of Monopoly. It doesn't need to inherit from Monopoly. It can just have an instance of Monopoly game, right? Because our game class should be separate from user input, right? Because you don't know if it's going to work in a console application or a web application or a mobile application or whatever here, right? You want it to be separate and distinct. So you have a instance of it, not is a. Right. So let me go add a new class here, and we want a rectangle. Rectangle. This one extends is our keyword for this one. Extends polygon, but it wants to suggest tests. Again, not always the right answer here, right? So yeah, we're going to extend polygon. Great. And now it's mad at me right away because there's no argument constructor in Polygon. You can't make an instance of Polygon without calling one of these constructors here, right? So we need our constructor for rectangle to call the constructor for Polygon. It's still familiar, right? This is all boring review from 200. If I'm going too slow, just holler at me. We can speed it up. But sometimes it's good review. So our constructor then needs to go and do something. Now, do I need to track my length and width inside of rectangle? Probably not, right? I have a side lengths variable that I can use, right, to go get those lengths and widths out, right? So I don't need to also store it here and then store it there. We could, right? You're not going to use up too much memory by storing two more doubles here, but we don't need to, right? So all we need to do then is have a rectangle constructor. Now, again, the suggestion here is terrible. We don't need to know how many sides are in rectangle here because we know a rectangle has four sides, right? So if we know we have four sides here, we can call my polygon constructor given four sides. That's not the right keyword here. Super, there we go, super. Sorry, super four. So super says, hey, go call my super class constructor with four, right? If we wanted to have a rectangle here, constructor that takes not an int for number of sides, nice, a double for length and a double for width here, we can go and do that. What this needs to do is call the superclass constructor, right, and go and give it the list here. Now, if we have side lengths here, and you gave me the side lengths, one of the things we didn't check is that you told me it has three sides, and it actually has three values in the side lengths array list. Right? You should probably have that. This might even be fine as a regular array, right? Because you shouldn't be able to go add new ones once we've made it, right? We don't really want to go and add and change it, but we're not going to let people do that anyway. Uh, so we could infer number of sides from side lengths, right? I think that makes sense. So instead of taking that as an argument here, we're going to go and change it up, and we're going to take side lengths dot size. Look at that suggestion. Fantastic. But now it's like, oh, you're mad at my tests here. I don't need to tell it there's three sides anymore. Great. So we're just, as we're working through this here, we can go and change stuff. Perfectly fine. And I have unit tests that I can still run to make sure what I changed doesn't break, which is nice. So now this needs to go make a new array list then, right? So array list of type double is a new array list. Arrays as, look at that suggestion. I love it. But it's length, width, and length and width again, right? Again, the suggestion was not perfect here. You're going to hear me complain about AI suggestions forever now. My apologies now that I've turned this tool on here. Uh, right. Now I have that lengths. Now I can call my superclass here, super, and I can give it lengths here. Oh, but it's mad at me. Your super constructor has to be the very first thing your constructor does. Well, that's unfortunate, right? Okay, well, what can we do more? Let's we gotta call it first. But length doesn't exist. Okay, well, we have to pass it this thing here. So we essentially don't have to declare. We are gonna just create that in line, which is a little bit messy. super of a new, of array list, of arrays as list, of length width. Well, I'm not proud of that code here, but it works, or it should work. We'll find out, right? Uh, it's a little bit messy as we start doing this here, but that should work for us, right? So you make a new one here. You got 4 sides. If you know length and width, great. We set length and width here. Now, to keep you from going and changing one side length, right? Because you can set one individual side length here. We need to override this behavior, right? We need to make sure that if you're using rectangle, you can't go set just index 0 because then I'm not a rectangle anymore, right? 0 and 2 have to be changed, and 1 and 3 have to be changed. My lengths change and my widths change, right? So we need to go override. So we're going to add an at override here and say this is for the public void set side length here. Great. So no, we don't need to do our own argument checking here, right? Because that'll already happen in my superclass. I don't want the same code twice, so I should feel bad about myself if I have the same code twice. That's a pretty good rule of thumb. So don't need any of that. What we need to do is call my superclass set side length, given the index and the length, right? But I really want, if this is 0 or 2, I want to set both 0 and 2. And if it's 1 or 3, I want to set both 1 and 3, right? So a couple ways we could go about that here, but I'm just going to say, hey, if my index mod 2 is 0, right, that means it's 0 or 2, right? I'm going to set 0 and 2. Otherwise, I'm going to set 1 and 3. Does that seem fair? Right, so we'll set 0 at the length, and then we'll set 2 at the length. Right? Again, lots of ways we could have gone about it here. This is just the first thing that popped in my head here. Slow down, IntelliJ. It's not empty for long, right? And then we set this one still as length, but really it's the width, but we're just calling it length. It doesn't particularly matter here, right? Is that okay? So now we have set side length. We've overridden that behavior. Now, this at override is an annotation. That's just a fancy word for it. It's not really code. It's saying something about the code. And what it allows me to do is get compile time checking, saying, hey, I meant to override something here. If I screwed something up, it's going to yell at me and it's going to say, doesn't actually override anything, which is super helpful, right? Because we want our tools to check that for us, right? Because we make typos all the time. So the annotation allows that compile time checking for us. Not technically code, but sure, it's annotating the code. Right? So these are pretty cool. We'll see these in a couple places here, and you can do fun stuff with annotations. Right? We were actually had them in tests, right? We said, hey, this is a test, right? And we just sort of let the magic happen. It was fine. Okay, so we have set side length. Now, we are a special version of Polygon. We are a Polygon, but we can also do new things, right? So the new thing we get to do then, right, is we have a public double get area, right? Get perimeter, already been written. It's not going to change, right? But area now I can compute here. So I'm going to return, I guess we don't want to do it twice here. So we'll get the um, array list of doubles here for sides. Oh my goodness, no. Side lengths is super.get side lengths here, right? Let's get out our side lengths, and then I can return side lengths dot get 0 times side lengths dot, no, that's not correct either. 0 times 1, length times width, right? Sure, we can get our area out. And then if we wanted to, we could add more functions, more methods here to make rectangle be a little bit more usable, because just by looking at this API, my public methods, right? This is my application programming interface, the abstract way of interacting with rectangle. If I give you a function that says set side length, are you going to know you only have to give me 0 and 1 and that'll do the rest? No, you have no clue. I could leave a comment here and be like, oh, by the way, if you set 0, it sets your length. If you set 1, it sets your widths. But why bother doing that when we can have code, right? Code should explain that sort of thing. So we can have more functions like set width or set length. Length, oh my goodness, I can't spell. Length given a double for length. And no, that is not what I want. I want to call my set side length here, given we said 0 was the length, right? And 0 and 2 get set, right, when you call this one. So calling myself, we'll call my superclass twice, right? We can follow this chain of execution down here. We're going to call polygon set side length and polygon set side length, right? Great. And then we'll have a set width here, given a double for width here, and width. And we're going to say, hey, that's the one, right? Set width. Right, good old-fashioned copy-paste. I like it. Still calling it set side length, but I'm handing it the width 1. We'll do 1 and 3. Right? Very exciting stuff. Nothing new in inheritance, right? You all look really bored. I'm sorry. Uh, that's how we do it in Java land. Good so far? Right? Now, what if we wanted to make a special version of a rectangle? You guys guessed it. You want to make a square. Yes, you're all so excited for squares. Right? Works the same way here. So square extends, rectangle. Okay? I don't want a square with a length and a width, right? But sure, I'm going to take all of this. I want a square with a length here, and I'm going to set length and length, right? Pretend you're a rectangle with length and width of length, right? Perfectly fine. Or if we don't know, right, we want a public square, um, no arguments here. We just call super with 4. Hey, you've got 4 sides. I can't spell square. That's embarrassing, right? Call, rectangle doesn't have that. Shoot. So that's just superclass. Sorry. Rectangle knows it has 4 sides. Right? Square doesn't need to tell rectangle it also has 4 sides. I bet. So two constructors again, because we need to call our superclass constructor. Now this one would be okay without any, right? The first time we did rectangle, it yelled at us and said there's no argument constructor for your superclass. Right? Inheritance works through that relationship because square is a rectangle. Rectangle has a no argument constructor. You don't have to have one for square, right? But we're going to write it anyway here. Oh, it's not undo. There we go. We'll write it anyway because we want our code to be easily accessible and usable by other people. We want a nice abstract interface that people can use, right? They don't need to have the default no argument constructor. I'm going to give them one here. Hey, you know the length? Good. We'll go and set it. Now, to set length and set width here, because square is a rectangle, those functions will be accessible. If you set the length separately from setting the width, you put my square into an invalid state here, and our classes should not allow themselves to be in an invalid state, right? So we need to go and override some more behavior. Very exciting. So we're going to override my public void set length, double for length. We're going to call set length, and we're going to call super.setWidth here, given the length. Right? And then we're going to do the same thing for set width here. We're going to override the behavior for set width, doing setting length and setting width here. Now, it also has this version of setting side length, which is still invalid for square, right? So we need, if you set any index here, they all change, right? Again, just make sure we protect the integrity of our class here. So a bunch of overrides here. You thought square would be easy and have not a lot of code, but it needs a bunch of code. Public void set side length. Really? Side length? Why? It's not. Really should come up with that for me here. I really want it to type it for me. Override, void set, side. I'm sad. Why is that not working? Int side index and a double from side length. There we go. Sure. All right, now it worked. So if you call set side length here, I need to call both my superclass ones, or I can just call my own set length and set width. Right? I don't have to go to the superclass immediately. I can go to set width of mine, which will go to the superclass setting these ones here, which will then go to the superclass, which sets both, and back to the superclass of, we've gone too far now, right? But it'll eventually get to Polygon to set an individual side length here. So whatever approach you want to take, perfectly fine, right? There's multiple ways to do it here. I'm just going to use my own here. So I'm going to set length here, not to set side length, no, set length here, given the side length, and then set width here, given the side length, right? So I'll use my methods here that call my superclass methods that call my superclass methods, right? Great. Now, notice I only have super here. There's no like super. I can't really get right to Polygon. Unfortunately, there's no direct access that way here. And our access modifiers here work the same way. So the default modifier for this one, right? I didn't actually say, hey, this should be private here for side number of sides and a private array list for side lengths here. Now it's warning me, hey, you could make it final. So you set it once and it's fixed. That's probably fine, but I don't have a way to change this value anyway. So let's just do a get for this one maybe, right? I don't actually, I didn't want to set. I just wanted to get here. So you can get out how many sides it has. Sure. You can also get the side lengths and count it here, but that's okay. Uh, so number of sides could be final. Right? That is my special keyword saying it gets set once and then you can't change it in code. Right? And then what does it complain about for side lengths? Could also be final, right? We set it once in the constructor. This way you can't change the instance of array list it's pointed at. Because it's an array list, you can still change the contents of that array list by adding or removing from it, but you can't change where that array list is pointed. That's probably fine. Sure, we can mark that one as final. It's not going to hurt anything, right? The constructor job does that. Now, we've marked it as final, so rectangle doesn't have access to that, right? There's no other attribute here. There's no side lengths, right? Here, you can't get at them. Now, if we wanted to give access to our private classes or our inherited classes, right, we can mark these as protected, right? Protected gives access to subclasses here. So now I can say, hey, my number of sides equals 2 or something ridiculous here, right? Now, of course, it's not going to work because it's final, right? But, okay, so sure. Okay, let's take out that final keyword now. And now I can go change it here. So I could directly say, hey, this one has 4 sides if I wanted that sort of thing. We got lots of choices here. And then all the way down in square, right? We could say, hey, my side lengths, number of sides is also 4 if we wanted. So it works all the way down through that chain because any inherited class will have access to it with that protected access modifier. So it's not just the immediate child class, uh, right? Okay, but we don't want to do that, so we're not going to bother with that one here. So I'm going to go back and comment that one out here and say we don't want protected here. We want a private int for number of sides. Okay. And sure, okay, mark it final. It'll be happy with final. Right, so we don't want this here. Only works if the value is marked as protected. Is that a helpful comment? I'm not allergic to comments, I promise, but I just don't usually put them in. If you'd like more comments, I'm happy to put them in here. All right, works the same way so far. Nothing new and exciting. Now, abstract classes. Remember those from C++? I think they use the virtual keyword, right? You could have a pure virtual class or just a virtual function. Get a couple head nods here. Okay. So if we wanted here, we could say you can't actually make a polygon here. You can only make subclasses of polygon. It's a choice, right? You're welcome to do that here. It might be more interesting if we had other instances of polygon, like maybe I have a triangle class, right? We could do something like that. So we could have another class then here. This will be triangle here. And triangle then extends polygon. Now, triangle knows it has 3 sides here, so we can call super with 3 sides, or we can make a triangle given a double side 1, I don't know, length, a double side 2 length, and a double for side 3 length. Sure, we can go and do that, and then make a super, right? We want to call our new array list of type double with arrays dot as list given side length 1, 2, and 3. Sure, very exciting. Okay. Either constructor, perfectly fine. Now, setting individual side lengths of a triangle, probably fine, right? I don't know any math way of making sure that you actually have a connected triangle just given side lengths. There probably is a way. I'm just bad at geometry or haven't used geometry in a bunch of years. Right? Is that okay? But interestingly, there is a way to get area. So we could have that function. So if we wanted to always have every polygon be guaranteed to have a get area function, we could write that as an abstract method, right? So in my polygon class, I can have oh my goodness, I don't even remember where the keyword goes here. I should go look at this here. We'll come back to it. That's Java abstract method. I'm going to Google it because I'm lazy. My apologies. Okay, was it? Did we get it here? Abstract class, public abstract void. Okay, there we go. So we're going to mark this class as abstract here. And now there's problems because you can't actually test an abstract class here, right? That's a bunch of big no-nos. So just comment that out for a second here. Okay. And then I can say, hey, I want a public abstract double get. Wow. I knew I want to get area. I'm kind of impressed. That's a little spooky. And it says, hey, there's one implementation, right? I've said this class here will have a get area method. I don't know how to define it because as a generic polygon, I don't think there's any way to get the area of a generic polygon. Probably not going to happen, right? If you know what specific kind of polygon it is, then we can get area. So if you know it's a rectangle or you know it's a triangle, sure, we can get the area. We can come up with other ones too. I'm sure there's formulas there. We just don't care that much about it, right? So now in triangle, it's yelling at me here and saying, oh, it must either be declared abstract or implement the abstract method. Right? Same idea here. If you are inheriting from an abstract class, you then have to implement its abstract methods or yourself also be abstract. You can have an abstract class that inherits from an abstract class that inherits from an abstract class. Depending on which textbook you had for 350, you saw a bunch of that nonsense. And that hurts my head when we get to trees. But that's okay. We don't have to do that. So we want to implement, right? That's my suggestion here. Implement get double. Great. Well, how do we do that? Well, again, it's marked as override. We're not really overriding any behavior, but yeah, we have the mark here, which is interesting here. Again, is helpful because it makes sure that we typed it correctly here. So there is a formula for the area of a triangle based on the side lengths. I know this because I've done this example way too many times, and it's based on the semi-perimeter, which is super exciting. Right? I don't remember what it is. I'm going to go Google it here, but area of a triangle from side lengths here. There we go. The Heron's formula. Lovely. The area is the square root of the semi-perimeter times the semi-perimeter minus A times the semi-perimeter minus B times the semi-perimeter minus C. Sure, we can do that. Okay. The semi-perimeter is half the perimeter, right? So to calculate that, we need a double for semi-perimeter, right? Semi-perimeter is my get perimeter, right? Divided by 2. Easy, right? I can get perimeter from polygon. I don't have to write that one here. And then I can return math dot square root, oh no, capital M math, right? Math dot square root of the semi-perimeter times the semi-perimeter minus side 1, get side length 1. Okay, that's going to be a little bit ugly. So double side, an array list of doubles. List of doubles for side lengths is get side lengths here. So times my side lengths get 0. And now we need some order of operations. Right? Thanks for pointing that out here, because otherwise we're going to do our arithmetic first here. Not doubled here. Okay, that times this one, parentheses, right? Times the next one, times the next one here. So I'm going to just put them all down on one line here, because why not? Oops, this one here. Wow, look at that suggestion. I love it. I think it now needs one more parenthesis. That one needs another parenthesis. That one has the parenthesis. That's totally readable and legible, right? We're okay with this? It's probably fine here. Right. So we can get the area. I think that's the formula. Right. We can test it out and see. So a 3, 4, 5 triangle is base 1/2 times base times height. Right. So 3, 4, 5. A base is 3. The height is 4. That's 12. Half of that should be 6. Right. So let's go write a test. I'm so glad you wanted to write a test. Good idea. Go to test. We don't have one. Yeah, let's make a new test. Get area. Sure. So let's go make a new triangle. So triangle, and it's 3, 4, and 5. And we're going to arrange, and then we'll have a double for expected area is, we said 6.0, right? It's our double, and then we're act, a double for actual area. Look at that, I love it. And then assert equals expected and actual. Now this one might need the delta, right? Like something in here close enough, because we are doing division with floating point numbers, and computers are bad at that sort of stuff. Go blame the electrical engineers. I think they've been working on it for a really long time, and they don't know how to do it. And they do know how to do it better, but it'll make everything slower, and that's not really a good trade-off, right? And we can just throw away a couple bazillionths of a decimal. I just think it's probably a fair trade-off. Let's try it. See, is it going to work? It worked. I'm actually kind of impressed. I didn't expect that to work the first time. Usually doesn't. All right. So an abstract class, right, works the same way. We mark it as abstract. You have abstract methods that are implemented by your child classes here, right? Okay, nothing exciting and new here. We good so far? All right. I gotta run to the bathroom real quick. So why don't we take 10 minutes now? Just a little bit early. Is that okay? And then we'll come back, pick it up. We're gonna look at interfaces. That's a pure virtual class in C++. I don't know if you actually did those or not in 200. You probably should have talked about them. I talk about them when I teach it, but I don't know how far you got with it. We'll look at those in C++, or sorry, in Java, and then we'll look at some of those other fun things as well. And I'm going to show you some fun things you can do with interfaces, which is a design pattern you can use. When someone had asked, how do we test random numbers without having to, I know this C will give me 379 here, and I can test it out. And we've got a fun way we can use interfaces to do that, which is really cool. All right, so we'll take 10. Remind me to unpause when we come back, please. Alrighty, welcome back. All right, so the next piece we want to look at is interfaces. Um, this is ever so slightly different than C++ land, and slightly different than Python land. In Java, you can only inherit from a single class. So you'll get single inheritance. So if there's more than one abstract class or pure virtual, purely abstract class you want to inherit from, you're not allowed to. What you can do is you can implement interfaces, more than one interface. And this is relatively common with a lot of the other major object-oriented languages here. So if I wanted to have two different pure abstract classes here, um, come up with other sorts of examples here, like, hey, this is a flying vehicle sort of thing, and then here's a driving vehicle sort of abstract class, and they're just virtual with a method like drive and fly. And all of a sudden you want to build your flying car, because apparently they're selling those nowadays, and I would be scared to fly that around with people shooting drones out of the sky nowadays. But some rich people want to waste their money on flying cars and be the first one to have one, and go for it. You do you. So you would want to implement both interfaces, but you can't extend both as abstract classes. So if we were to write an interface here, rather than, oh, let's do them at abstract classes first here. So we'll have a flying vehicle here, and we'll say, hey, this is an abstract class flying vehicle, and maybe we say, hey, it has a public abstract string fly function here. I don't know why, but this one can fly. And then we had another one for I don't know, driving vehicle, land ve land vehicle? I don't know. Vehicle, is that one okay? And we'll say this was an abstract class as well. Oh, sorry about the Coke. Abstract class, and this one has a public abstract string drive here. Sure. So we've got both ones here. So if we wanted to make a flying car class here, flying car, it can't extends flying vehicle and flying no, land vehicle. We can't do both. Sure, implement the method. So now it's still upset with me, right? You can't extend multiple classes. Not allowed. Okay, I was really amazed it actually let us do that. But no, it doesn't actually work. So we override both of them, but you can't be both things. Right? This creates a single is a relationship. You have a single superclass if you want. Now that superclass can be another type, right? Inherited from another class. So square is a rectangle, which is a polygon, and then everything is an object, right? We got that clone function from object in Python. So everything implicitly inherits from object. The solution to this is to use interfaces, right? So we're going to go and mark these things as interface. So we're going to say, hey, this is an interface instead of a abstract class. And now, because it's an interface, all we need is, is that, oh, that's the one I'm missing here, sorry. You don't need to say it's abstract. By definition, because it's an interface, the only thing you can have is abstract functions. So you don't need to say they're abstract here. And it doesn't even need to say that it's public because it's redundant here. It's a public interface. You just have all of them. So it saves you a little bit of typing as well, which is nice. We'll go change this one as well. So it's not an abstract class. It's an interface here. And then we don't need public and abstract as well. Great. Now my flying car can, instead of extending, it implements these interfaces. Now we're okay. So you can implement as many interfaces as you want, but you can only extend one class. right? And that's the big difference here. So if you have this class has no implementation whatsoever, it's just a list of methods, that's an interface. And that word we use a lot of times. We have application programming interfaces. The interface is here's the list of methods and functions you have. So to write an interface is here's the definition of the list of methods that you have, right? You essentially interface with those public methods. So I can make, hey, here's the interface for this class here, and then I can go implement it in any way that I want, right? You're very familiar now with all the different ways you can implement with lists. Right? You can make linked lists, you can make array lists, you can make, oh my goodness, there's a third one here that we almost never do because it's terrible. Um, I forget what it is at the moment. But the implementation is hidden from the person using it. So if all we get is an interface, we just know it's going to do as advertised, right? If we want to know about how it's implemented because it impacts our performance, we're going to have to do a little bit more digging, and maybe you have some documentation about your classes or things like that, right? Or maybe you name it, hey, this is the array list versus this is the linked list, right? When you implement the list interface. So in Java land, Java API, there is a really fun website here, the Java Docs site. I don't know if you had a chance to look at this one yet here. There's a list of all of the classes here in the Java API, which is really fun. And there's a bunch of abstract classes up the wazoo, and they're all named abstract, which is fun, right? Go for it. So Java loves its inheritance. So abstract map is the base class for anything that implements map, like concurrent hash map, concurrent skip list, enum map, hash map, identity hash map, tree map, and weak hash map. Sure. The Java API documents all of the stuff, which is really fun, and shows you, hey, this is what it has. It extends object, it implements a map of key value. So map is the interface here, right? We're implementing a map interface as an abstract map here. Sure. So it's got a couple things here. It's got a couple methods, which is fun. So we can look up any of the Java stuff, and this is all what gets shown when you hover over an IntelliJ and you get that nice little documentation window. It's showing you the Java API. Right? This is the API documentation. Sometimes it's nicer to view it in web form, which is cool. So like here's the map interface, right? Just a map, and it has a bunch of methods. Like that's a bunch of things here. Holy cow, that we have all of our methods for, right? But sure, that's in the map interface. So if you want to implement map, you're going to implement a bunch of stuff. You probably don't want to build a map by hand. That just does not sound very fun here. So um, one fun thing we can do with interfaces here, and this is a design pattern here, when we talked about building out random number generators and testing random code, it's really hard to test code that generates random numbers unless we know what the seed value is, and you have to have a way to set the seed value, and those sorts of things get really messy here. We can do this dependency inversion. So a really fun technical term. So we're going to invert the dependency. So when my lottery class depends on random here, we're going to invert that, and we're actually going to give it a random number generator. So instead of it using one, we're going to hand it to it in the constructor. Right? So we'll say this is my interface for random numbers here, and we're going to write a public interface for random numbers, and it has a int next integer, given an int lower bound and an int upper bound. Something silly like this, right? Here's my public interface, okay? So if I want to write a lotto ticket class here, I can say, here's my ticket class here. Again, this is a bad example here. We could go through the real one, but that's okay. It will have, as an attribute, it'll have a random, oh my goodness. I just named it here. I forgot it already. Random numbers here. No, not random. Random numbers. And in the constructor for ticket, so public ticket, we're going to take an instance of my random numbers, call it random numbers here. And then maybe we'll have an int for number 1, int for number 2, int for number 3. Sure. And we'll just go set those. Oops, can't have spaces here. Sorry. We'll say number 1 equals my random numbers dot next integer from, I don't know, 1 to 10. Right? And number 2, sure, and number 3, look at that, autocompletes, great. So when you make this instance here, you tell it, here's an instance of this interface. Here's a class that implements this interface. Now I can go pick my 3 numbers, right? So what I do when I actually go and use this in the real world, I'm going to hand it a class that actually gives it random numbers. When I want to test it, I'm going to make a fake testing class that gives it fixed numbers. Sounds like a lot of work, but it's kind of hard to test random numbers because they're pseudo-random. So we can go then and make a class here. So here's my random, I'm going to call it a wrapper, which is very exciting. And we'll say this implements my random numbered interface. And it says, no, it doesn't. Well, that's fine. We'll get to that in a second. So I need a instance of random. We'll call it random. And then my public random wrapper then creates an instance of random. And then we can import, yes, no, not extract, import, thank you, import java.util. And now we can implement the interface, implement the methods, yes. I don't want to return a 0. I want to return my random.nextInt, nope, given the lower bound in the upper bound, right? So all we've done is we've written a class that wraps around the actual random class here, but it implements an interface. And thanks to polymorphism, another one of our fun technical terms for object-oriented programming, the ticket class doesn't care which class is implementing this interface. It says, you will give me something that has a method called nextInteger. I give it a lower bound and an upper bound. You give me a number back. So as far as ticket is concerned, I'm getting random numbers. Right? In this case, we are giving it random numbers with a random wrapper. But now I can make another one, bless you. And again, I don't have a test package. We'll get to that next chapter in a second here, but I'm going to make a not random class here. This is very exciting. This one will implement random numbers. You guessed it. And not random, then I'm going to make it an instance. We'll say let's get a integer array for numbers here. And I want to store those numbers. So I'll have an integer array for numbers. And then my this numbers can equal the numbers. Sure. And when I want to get a random number, nope, I want an int. Sorry, for get. Oh my goodness, I want the interface here. Sorry. I also need the int for the current index. And I'll set current index as 0 here, because this way I can get numbers out. Now we'll go implement the interface. Give me some code, please. And I'm just going to return the numbers index of the current index plus plus. So you can make an instance of this class here and you give me some array of numbers. Here's the first number, here's the second number, here's the third number. I will give them back to you as you ask for nextInteger in that order. It implements the same interface here for random numbers, but it behaves completely different. Right? So as I'm going to test my ticket class now, we can go to ticket here. And let's go write tests here. Oh, sorry, I need these to be, I need some gets here. Sorry, give me just a second. Let me go generate a get. Generate getters for numbers 1, 2, and 3. Great. Now I can get out numbers 1, 2, and 3. So we can go and set them right in the constructor. We can go and get them back out here. So now we can make a test here. Go to test, make a new test. JUnit 5 is fine. We want to test get number. I'm going to do them all once anyway. It doesn't matter here. Get number here. And we're going to arrange. We're going to act. And we're going to assert. Now, I understand this feels like a lot of extra work, and it is here, but I promise this sort of tool will make life easier for you. Being able to do essentially dependency injection. It depends on this thing, and I will give it to you. Right? Here's the thing you depend on. I can control it for tests. You can do it this way. And actually, we'll see there's some shortcuts we can use in just a little bit here with a different testing library. I'm just going to Google it for you because I don't think we need to go through and write all that interesting code. But I'll show you that in just a minute. So we're going to have my integer array for numbers here equals an integer array 1, 2, 3. Sure. Right. And then we're going to make some random numbers here. So I'm going to make my ticket, and I'm going to give it the numbers. Oh, I'm sorry, not the numbers. Not random here, and not random. I'm going to give my numbers to. New, sorry, new, not random. Nope, it doesn't need those. Sorry, I can give it 1, 2, and 3. Right? Nope, I had it backwards. We give it an array. Why is it not like my array? Not a statement. Ticket equals. Oh my goodness. New ticket given not random of numbers. New not random of numbers. It's been a day. It's been a day. It's a lot of new keywords. Sorry. So new not random, which implements the random numbers interface given these fixed numbers. I'll get numbers 1, 2, and 3 back out here when I ask for a ticket. So ticket gets created, it will use those numbers in that order here, and then I can go get my actual number 1, is my ticket dot get number 1. Oops, I did not mark those as private here. My bad. So those should mark as private, so you don't have access to them. Private. Right. I don't care if they're final or not. That's fine. Get ticket number 1, and then an int for 2 is get ticket 2. Int for actual number 3 is get ticket number 3, and then assert equals number. I want numbers of 0, actual number, numbers of 1, numbers of 2. Right. Very exciting stuff here. But now the test should run. And with a class that depends on random numbers, I can give it something that's not random to test the rest of the behavior. Like in our Powerball ticket class, I can now tell you, hey, here's your numbers, even if you didn't have a constructor that took 6 numbers. If the only constructor you had is one that just generated random tickets here, I could give you a not random class here that will generate a fixed set of numbers here instead of random numbers. And I don't need to pick a seed value and find that and go through all those hoops here. So writing our code in such a way, designing it in such a way, allows me to test those things that are hard to test. Right? This is a very common practice here. So common, in fact, there's a library to do it, so you don't have to write another class. Right? It's really obnoxious to have to write a not random class if the only thing we're doing is saying, "Hey, please give me these values back." Right? I'm essentially fixing what should come back from something interesting with something I know and can predict. So there's a library. Is it JMock? I want to say, or Makito? There's a couple ones out here. Is this one still a thing? Wow, this is ugly. Wow, get started. This is so terrible looking. I'm sorry. Is Makito prettier? I think that one might be prettier. And that one even sounds funnier. Makito. Makito. Oh, Makito. Yeah, sorry, no Q. Look at that. Makito site.makito.org. All right, this one looks a little prettier, right? Like quickly, why did we drink it? Wow, that's fun, right? Okay. How do I drink these people have a sense of humor. So anyway, what Makito lets you do is generate fake classes that implement interfaces without having to actually write the code. It will create a mock instance of that interface. Right? So it says, hey, I want a fake version of this here, right, that looks like one of these things, and now I'm going to go and say, here's what's going to happen, right? Um, so when you call get of 0 on your fake list, which looks like a linked list here, right? Then you should return this thing here. I don't think we need to go through and show the whole thing. I'm not going to ask you to use this, but I want you to be aware this sort of thing exists. And there are these sorts of libraries for pretty sure all the languages nowadays, because it's such a common practice to test classes that depend on other classes, and you don't want to have to test the other class. Right? A unit test should just test, does my class do what it's supposed to do? But if it depends on another class doing something, then I can fix those values. Right? Hey, when you call get 0, I'm going to give you back first. Right? Great. We can do that. Now, again, it will throw weird stuff here if you don't. It's called stubbing. You're saying, here's the behavior, here's the stub for that behavior I want to do, which is great. So you got lots of fun things you can do with value and some helpful hints, right? Don't mock types you don't own. Right? You should be mocking things that you have control over that you could go through this big step for. Weird stuff can happen otherwise. Don't mock everything. Don't mock value objects. So value objects that are only, we care about values, rather than references, those sorts of things. Lots of fun stuff. So this is pretty good. JUnit, I don't think there was a mock. Was there a JUnit mock? Oh yeah, this is okay. Makito again here. So lots of fun options here. Lots of ways to test. So if we write our code in a way where we take advantage of interfaces, we can go do this, right? Because we can mock those really quickly. Here I'm pretending to implement an interface that looks like this, which is nice. Right, I think that covers everything we're looking for with interfaces. Let's see, interfaces, right, and he's got more practice here. Sealed classes are obnoxious. They don't let you extend them. Is all. It's a fun keyword. Um, Inheritance versus composition. That's a is a versus the has a. Right. Composition means my class has an instance here. So your Monopoly game, the class that does your user interface, right, your console input and output, will have an instance of your Monopoly game class. Right? It isn't is a Monopoly game instance, right? Because it just has a. And there's the difference there. So, and it's a tool you have. Some people really love inheritance. It has good places you can use it, but you don't need to use it everywhere for that one. Right, and then interfaces, enums. I think you've done enums in C++. Right? You're putting a name to a type. Works the same way here. I don't think we need to spend too much time on that. But packages and libraries. This is an important piece in Java land. So everything we've done so far is actually a little bit improper. So we just have this source folder here, and everything is in source. And I don't know if you notice some of these things say, hey, from default package when you hover over them. Where is it here? Fly car. This one's not showing it. So sometimes it'll show you the default package. So a package in Java is just a folder. So all your files in a folder are considered in that package. And we give it a name. So in general, a default package is considered bad form. So this base example here is considered bad form. So what we want to do is we want to make a new package here. And here's stuff like more OOP. And now we have essentially a folder for all of this stuff here. We're going to drop all that in here. And then we're going to refactor. It says yes, to refactor those anyway. Oh goodness, really? Sure, do it anyway. See if it works. Um, the benefit of this here is we can better separate and organize our code. And at some point, you're going to write code that's good enough you want to give someone else. Not today. That's okay. But eventually you'll get there. You want someone else to have your code or to publish your code or do something with it here. So having separate packages allows us to organize that better. And then any of this test code we've written doesn't need to ship with that code. Right? When you go and give a customer code, they don't need all of that test garbage. It's not garbage, sorry, that's the wrong word, but they don't need all that bloat. So we can separate out all the test code from the main code here in a different package. So one of the things it said, hey, when we went to go test this, we say go to test, create new test. Before was saying something about a package, the default package. Now we want to change this from being our default package to a test package here. Great, and we want to test these things here. And I think it should make the test automatically for me here, which is nice. So I can move my tests into that one here. So polygon tests, move it into, oh, that one doesn't even work anymore anyway, but that's fine. And then triangle test will move into tests. I think that was our last test. We'll probably move the not random in there as well. That's probably fine. I think all of that works here. And ticket test should move as well, sorry. And then when it does the refactor here, it's changing the package name at the top. So if your code belongs in a package, in Java land, you say, hey, I'm part of this package. Now, it should match the folder name that it's in. So it's a little bit silly that you have to explicitly say it, but the folder name will match. And if it doesn't match, it's going to be upset with us, right? Hey, if I don't want this to be in the test package, I want it to be in the regular package, it's like, oh, it's not. It doesn't correspond with your file path. And then you think, well, if it's based on the file path, why do we even have to say it? But again, that's what we have to do. So we're going to change our package name. So this is a helpful suggestion to change the package name to the actual folder name it exists in. This one's usually fine to click on here, right? So again, we don't need any of this at this point here, but it's a good habit. It's a good practice for us to get into, and then we can build out these packages. And if you publish a package, you've turned it into a module. And you can import other modules, right? We can import things here from other packages, other modules. It's just another fancy term here. So, hey, this one says from the more object-oriented programming package, give me the ticket class, right? The org, JUnit, Jupyter API test, this comes from that package, right? For some reason, they love putting org in front of things. I don't know why they named packages weird ways, but somehow they decided to start naming packages weird ways. And you just smile and nod, right? That's fine. Some people put like com and other stuff in here, and you get some weird package names, and it's fine. They're just folders. It's not a big deal here, one way or the other here. But all of this should still work then, being in a separate package. And then when I want to go deploy my actual code to my customer and give it to them, here's my amazing lottery stuff, they don't get all of this other stuff, right? When we write our build package here to release it here, you can change your settings in the tools if you so care to exclude all of that stuff. Um, I don't actually remember how to do that in Java land because I don't publish Java packages here. In Visual Studio, that's you have a build release and you have, or I'm sorry, you have a debug release and you have a, that's the other one, a publish release or publish configuration. So you can say, here's the published version and here's what I want to build and test locally here. And you can separate those out with configuration. You can do all that same fun stuff here with IntelliJ. Um, Again, that's just good to know. We're not going to bother doing any of those fun sorts of bells and whistles here for our purposes. The code will still work, right? And that's okay. We're putting it all in GitHub, and that's all great here. So if I go check out GitHub, it's going to say, hey, there's a bunch of stuff. We have quite a lot here. Wow, 296. We made a lot of files already. And again, they just show here's the package, the folder that it's in, that sort of stuff here. So here's more OOP. And we'll push this one out. And then on the website, right on github.com, it's just a folder. So now I have my more OOP. I have a folder inside of the source folder for the more OOP package, right? I think actually that would probably even be moved out to the test packages. Like you can, instead of it being SRC, you'd have a test and you can organize stuff any way you want. It'll be fine. And you just manage that with your configuration. But we're able to divide those up, which is really nice. Modules and the Java doc you should be able to tackle on your own, I figure here. What do you guys think of the Murrock book, by the way? Is it, it's okay, it's good, fine. Apparently, we were supposed to use a different book. They didn't tell me. I don't know, but it was like a really expensive book from Pearson, and Murrock is not very expensive, and I was really happy about that. So I don't know what we'll do next year, but someone who is more important than me will tell me what book to use, and I'll smile and nod. Yeah,
Like last quiz, I got questions on networking and stuff.
really?
Yes.
Were they not? They should have
It
been.
was like one of them. At least I didn't recognize the topic. Sure.
Yeah, they should have just been from the test banks 8 and 9 if I did it right. It's possible I screwed something up. If you want to show me, we can take a look at that after. Yeah, I'm just using the Marocs test banks. Again, it's your incentive to open the book and read it. They're free points. They should be free points, right? They're not timed or anything. So most people will read the quiz questions first and then go read the textbook. That's kind of a good way to make sure you're picking up all those answers there. Um, and should go relatively well. So we're doing pretty good in the course. So this will end the last bit of console-based programming. Hooray, we finally, next week, will get to graphical user interfaces where we have buttons to click on and text boxes and things that actually show up on the screen rather than the black box. Hooray. It's actually very exciting. So the plan is to spend about 2 weeks on those chapters here. Project 3 will be a graphical user interface application project. So you'll go and build something with buttons and text boxes and things you can click on and do all sorts of fun things here. And then on the 9th, I'll give you essentially the plan for the midterm here. It'll be a bunch of quiz questions from the same test banks. You may or may not have had the question before. I don't have a good way to filter those out. So sure, more free points, essentially. And then I'll have probably just 3 long answer questions. I'd say write some code to do something. My plan, I don't even want to put a time limit on it because that's kind of obnoxious too. So it'll open on 10/16 at 6 p.m. If you'd like me to show up and watch you take it, I can drive in here and watch you take a test. Or at some point before 6 p.m. on 10/23, you can take it at your leisure, turn it in when you're done. So if you like taking tests in the morning, take the test in the morning. If you like taking the test over the entire week, take the entire week. Right? This is just a checkpoint. My goal is that it's easy. If it's not easy, we've got to have a conversation. Something's not connecting right with you in Java if this is not easy. Okay. Again, it's worth a decent chunk of your grade, but not a very large chunk of your grade. I think exams are stupid, but if I don't put exams on my syllabus, I get weird look from people. So we'll have that as sort of a checkpoint here. So it should be pretty quick. The goal is you could take it. I aim for an hour and a half so that if I were to sit and watch people take it in a 3-hour session, if they took them twice as long as I think it would take them, they would have time to get it done. So again, a couple quiz questions, probably like 30 quiz questions, and then like 3 long answer questions here. The plan is each one of those takes you maybe 20 minutes, and then you've got a minute per short answer quiz question, multiple choice stuff like that. Should be able to get it done in an hour and a half is the goal, right? But again, I'll open it on the 16th. It won't be due till the 23rd. Open it, close it, come back to it whenever you want here. perfectly fine. As long as you get it in by 6 p.m. on the 23rd, I'm good with it. If anyone wants, I can go over the answers to it on the 23rd. Most people are very excited about the midterm questions. They don't particularly care because they weren't hard questions. But again, up to you. It's your time. And then we'll move into the advanced portion here of here's a bunch of other cool things we can do with Java and then databases. And our fourth project will be based on databases. So interacting with the database via code is really cool and really fun because I think I mentioned before, pretty much every piece of information in the world exists in a database somewhere. So if we can access it and manipulate it and do something with it here, we can do lots more things than we could before. And databases are really the good place to store stuff. Local files, fine, interesting and all. But most of the time, we're going to interact with databases for any sort of enterprise application here. Um, we'll spend 2 weeks on that here, a little more advanced database stuff, and then we'll get into a couple weeks of multi-threading and networking. Networking uses multi-threading, so we got to get into that first here. We'll talk about our final project and get started on that. It's all supplemental material Dr. Ball was kind enough to share with me, which is great because he usually teaches this class, but again, took a more advanced course they needed him to do. That was the same time. And we'll do that for a couple weeks. We should have time in each of these weeks for you to work with your group on the final project. Okay. If your group members are ignoring you and not helping, please try and engage with them and then let me know. You're welcome to fire people from your team. And if you don't complete a group project, you fail the class. Right. But everybody should be free Thursday night because no one knew before you signed up here that I would say, hey, I'm going to record them for you. You don't have to come. Right. So don't let them tell you they're busy Thursday night because they should not be busy Thursday night. Right. Okay, we'll go from there. We got Thanksgiving break coming up on the 4th. I have no plans to say anything new. The plan is just to give you more time to work on the final project. Um, Ideally, you can be done by the 4th. Again, I would love for everyone to be done by the 4th so that actual final exam week, you can focus on the stuff where teachers want you to have to memorize and regurgitate a bunch of information. I don't care if you can do that or not. I care if you can write code. So when we do our final project presentations, it'll be your turn. All the teams will get up and run their program, show us how it works. Ideally, you can plug into the projector. If that doesn't work, we can host a Zoom call, and then you can screen share from your laptop. We can make it work, right? We got enough technology that should be good, and they'll all be networked-based applications. I would love if people came up with their own ideas for these. Again, we'll talk more about it when we get close to the final project. It's really boring if 15 teams all do the exact same project. Right? That's just really dull. So if you want to come up with your own idea for, hey, here's a multiplayer sort of something or other, we'll do a chat application as the demo. So you can't do a chat application, but if you want to do something, hey, here's a multiplayer game. That's a lot of fun. You can do some interesting stuff with it here with our graphical user interfaces here. Poker's a lot of fun. If you like card games, that sort of stuff here, we can make it a multiplayer poker game. You can host a server that players can connect to and those sorts of things and do that fun stuff. So we'll talk more about that as we get closer. But questions, thoughts, concerns?
Pretty enough question. When you select networking, what exactly are those?
So we will figure out how to connect to other computers and other servers and other sorts of devices. So not local here.
APIs and stuff?
This is actually the low level bit of how do I send out a network request to another computer and do something over the network. Um, yeah, part of that we should be able to communicate with public APIs. So web APIs, it's very common. We'll spend some time doing that here. So if someone has a web API, we can interact with it in Java land here. But at this point, this is actually the low level. I'm going to build a server that clients connect to over the network manually with my code. So I'm going to build the server code and I'm going to build the client code. I can run the server code here. I can run the client code here on two different devices, and they'll talk to each other over the network.
Sounds good.
It's a lot of fun. It's a pain in the butt to do that, but again, that's how we write client server applications that are not HTTP based. Right? If it's not a website, we need some way of communicating here, and this is a very common, popular platform for doing that sort of stuff. And if it's all custom built, you can do anything you want with it, which is really cool. We're not limited to, hey, here's your GET request or your POST request or your PUT request, your common HTTP types. Right? Those are sort of limiting in that form. So lots of fun stuff coming up the pipe here. But we're essentially a third of the way done, right? The second third will be graphical user interface applications and databases, and the last third will be the multi-threading and networking here. So at this point, we've covered all the basics of Java here. Probably nothing new from C++ or Python. My apologies, but again, getting through those basics so we know how Java works, those sort of fundamentals, and now we can move on to the fun stuff next week. Okay? Awesome. I don't actually have too much more for you here. Again, it's all concepts you've probably seen before, so I don't think we need to beat them to death in Java land here because you should be familiar with the concept. Now you've seen it in Java, you should probably be able to do it again yourself. Is that okay? I'm happy to give more examples if you'd like. We can spend all the time you want here in it, but I don't want to keep you longer than you need to, and you've got a project to work on because no one's turned that one in yet. And a pretest. Don't forget you have a pretest to take. Very exciting pretest. You probably need one in Python. I can figure that out. Um, or just give me no answers because you don't know C++. That's okay. That's a valid submission.
Yeah.
Yeah, they haven't really worked through the fact that we don't actually have everyone having done C++ here. Especially, we get a bunch of transfer students too who haven't done C++. So um, it's a funny world.
When's it?
Whenever. I put December 4th as the due date. So sometime before the final project would be good. Um,
What is it?
it's in Canvas. So it's 3 questions. It's writing some code. Yeah. All right. Awesome. I'll go ahead and stop recording.